Welcome back to the deep dive. We're here to cut through the noise and focus on the critical insights you need for top-tier turf management.
That's right. And if you're a professional turf manager listening, you know your livelihood depends on delivering really consistent turf performance, season after season.
Absolutely. There's just no time to waste, no room for error. It's high stakes.
So for this deep dive, we're zoning in on optimizing turfgrass fertilization. We've sifted through the research, the best practices.
And the goal is to pull out those, crucial nuggets of knowledge, the things that really help you make informed decisions for consistently high-quality turf.
Exactly. Which brings us to the core challenge, doesn't it?
It really does. It's this constant balancing act. How do you get that lush, healthy turf everyone wants, while also being environmentally responsible and keeping operations efficient? It's tricky.
It is. It's a complex puzzle. So let's start unpacking that. We know why we fertilize. Turf needs nutrients, basic stuff.
Right, we get that part.
But the real goal of optimal fertilization, it's not just about, pushing green growth for looks.
Okay.
It's about providing the precise nutrients needed for strong plant growth, enhancing functional value, think wear tolerance.
Ah, right. Especially for high-traffic areas, sports fields, busy lawns.
Exactly. Building that resilience so it can stand up to the stress. That's key.
So precision is the name of the game, and that naturally leads to thinking about what happens if you get it wrong, because it's kind of a paradox, isn't it?
How so?
Well, achieving top-quality turf isn't about just dumping more fertilizer on it.
Oh, absolutely not. It's about hitting peak performance with the minimum effective amount of added nutrients.
Because overdoing it is wasteful, obviously, but it can actually hurt the turf.
Definitely. It can harm turf health, increase disease susceptibility, and cause significant environmental issues like runoff, things you absolutely want to avoid.
Okay. So let's talk nutrients briefly. We know the big three: N, P, K, nitrogen, phosphorus, potassium.
And the secondaries, calcium, magnesium, sulfur, plus micronutrients. But the ones needing the most attention year after year.
Nitrogen and potassium, right?
Yeah.
Because they're mobile in the soil.
Exactly. They move, they can leach or get used up, so they typically need annual replenishing.
Got it. So focusing on nitrogen then, what are we looking at for annual rates? What do the sources suggest?
Generally, the recommendation falls between 2 to 3 pounds of actual nitrogen per 1,000 square feet per year. That's a pretty standard range.
Okay, 2 to 3 pounds N per M. But you mentioned regional differences.
Right. If you're working further south in the Midwest, say, where the growing season stretches out longer.
More time for growth.
You got it. Rates up to 3.5 pounds N per 1,000 might be justified there to maintain that quality throughout the longer season.
Now, you mentioned something really interesting before we started recording about lawn age.
Ah, yes. This is fascinating stuff. Research shows that the actual nitrogen content stored in the soil tends to increase as turf gets older.
Really? Up to a certain point.
Yeah, up to about 30 years after establishment, believe it or not, which leads to a pretty counterintuitive idea.
Which is?
That brand new lawns, maybe in their first, say, 3 to 5 years,
Yeah.
they might actually warrant higher annual N rates, maybe even up to 4 pounds N per 1,000.
Wow, okay. So more N up front for new turf, then potentially dialing it back as the lawn matures and the soil builds its own reserves.
That's the implication.
Yeah.
It really underscores needing to tailor your program, not just having a one-size-fits-all approach.
Yeah.
You need to consider the age of the stand.
That definitely changes how you might think about setting up a new client's program.
For sure. Now let's switch over to phosphorus, or P. This one often comes with red flags for managers.
Because it's often regulated, right? Especially near waterways like the Great Lakes.
Precisely. Many states have laws restricting P applications. So the guideline here is pretty clear and very important.
Which is?
Only apply phosphorus if the soil test specifically shows a deficiency. Don't guess.
And you absolutely need to check local rules.
Always. Consult your state or county extension office. They'll tell you the deficiency levels that trigger an allowable application in your specific area. Don't risk being out of compliance.
Makes sense. And this ties into those broader best management practices, the BMPs, for protecting water.
Absolutely fundamental. Things like never apply any fertilizer to frozen ground. Seems obvious, but crucial.
Right, because it'll just wash away with the first thaw or rain.
Exactly. And don't apply if heavy rain is forecast. Same reason runoff.
And sanitation. You mentioned that's key too.
Hugely important. Sweeping or blowing fertilizer granules, leaves, grass clippings off impervious surfaces.
Like driveways, sidewalks, patios.
Yes. anything water can't soak into.
Yeah.
Getting that material back onto the turf is critical to stop nutrients washing straight into storm drains and then into surface waters.
These small steps really add up environmentally.
They have a massive collective impact.
Okay, so we've covered the why, the what nutrients, and how much. Let's get into the what form of nitrogen, because wow, the options.
It can be dizzying, right? You walk into the supplier and see quick release, slow release, controlled release, coated, stabilized, organic.
It's a lot. But you said they all basically try to solve two main problems with nitrogen.
That's a good way to think about it. Problem 1. Nitrogen often gives a short-lived response in the turf. Problem 2. It has a tendency to, well, escape through leaching gas off.
Okay, so let's break down the types. Quick release first. What are we talking about there?
These are forms that are immediately available for the plant to take up, often inorganic salts like ammonium sulfate or urea.
And the pros?
Well, they work fast, their release isn't really dependent on soil temperature, and the cost per unit of N is usually lower.
But there have to be cons, given the risks you mentioned.
Definitely. Higher risk of nitrate leaching down through the soil, higher risk of ammonia volatilization, where N turns into a gas and floats away, and potentially a higher risk of turf burn if you overapply.
So there are limits on how much you should put down at once.
Absolutely. With quick release N, you really shouldn't apply more than about 0.5 pounds, half a pound of N per 1,000 square feet in a single application.
Half a pound max per application for a quick release.
Yeah.
Got it.
Sticking to that minimizes those significant loss pathways and the burn potential.
Which naturally leads us to slow-release nitrogen options. These are designed to counteract those quick-release issues.
Exactly. This whole category is engineered to release nitrogen over a much longer period. Think maybe 8 to 12 weeks typically, sometimes even longer.
And the big benefit there is?
Significantly reduced nitrate leaching compared to quick release. They hold on to the N better, releasing it more gradually as the plant needs it. More efficient, better for the environment.
Okay. What types fall under this slow-release umbrella? You mentioned synthetic organics.
Right, often based on urea reacted with other compounds. A common one is urea formaldehyde, or UF.
UF?
Within that, you have things like methylene ureas. These have longer molecular chains, meaning they break down slower, give you that extended release. They're pretty widely used.
And you mentioned ureaforms, too.
Yeah, ureaforms have the longest chains, the slowest release of the bunch. But they tend to be maybe less utilized, partly because of cost and very slow release.
So for practical purposes, methylene ureas often hit a sweet spot.
They often do. Good balance of extended release, performance, and cost effectiveness for many standard programs.
Okay. Then there are the coated products. How do those work?
This is different. Instead of complex molecules, you're taking a standard urea granule and literally coating it with something.
Like a protective shell.
Exactly. Like polymer or resin coatings. This coating slows down how quickly water can get in to dissolve the urea and how fast the dissolved nitrogen can get back out.
And the release rate depends on the coating itself.
Precisely. The coating thickness, the type of polymer, that's what controls the release. Polymer coatings are great because they're durable, resist cracking, and give really precise, predictable release based mainly on soil temperature.
That sounds pretty advanced.
It's very smart technology. It's come a long way.
Now, you made a point to distinguish slow release from stabilized nitrogen. They aren't the same.
Correct. It's an important distinction. Stabilized N products aren't about a physical coating slowing release. They contain inhibitors.
Inhibitors, like what?
Things like urease inhibitors, which slow the conversion of urea to ammonium, or nitrification inhibitors, which slow the conversion of ammonium to nitrate.
Ah, so they're interfering with the soil chemistry, the microbial processes, to keep the nitrogen in a less mobile form for longer?
You got it. The goal is reducing loss by slowing those natural conversion steps, not by physically metering out the N over weeks like a coated product.
Okay, clear distinction. What about organic options, like meals or composts?
Yep. Recycled organic products, things like composted biosolids, bone meal, feather meal, they're natural sources, which some people like.
But there's a catch.
The main drawback, usually, is their phosphorus content. They often contain a noticeable amount of P, maybe around 2%.
Which brings us back to those P regulations and runoff concerns.
Exactly. If you rely heavily or exclusively on these, especially over the long term, you have to be really careful about P loading and check your local rules. An all-organic program based solely on these isn't generally recommended because of that P issue.
So, given all these choices, quick, slow, coated, stabilized, organic, what's the practical approach for most turf managers building a program?
Well, the reality is most commercial fertilizers you buy are actually a blend.
A mix of quick and slow release?
Usually, yes, combining the immediate availability of some quick-release N with the longevity of slow-release sources. For a solid annual program, the general recommendation is to aim for about 50 to 70% of your total annual nitrogen to come from slow-release sources.
50 to 70% slow release N, that provides the foundation for consistent feeding and environmental protection.
That's the idea. It gives you the best of both worlds.
Okay, this is great. We've covered the what form. Now let's pivot to application timing and scheduling, the when and how.
Right. Because it brings us back to those three key decisions for any application. The best rate, the best timing, and the best source for that specific situation.
Let's focus on cool season lawns in the Midwest. Typical growing season is, what, April through October, roughly 7 months.
Generally, yes. And the months where you see the most active growth, where fertilizer really makes a difference, are typically April, May, June,
And then again in the fall.
September, and October. Those are your prime application windows.
What about the summer months, July and August?
That's often a tricky period. High heat, maybe less rain. Turf growth naturally slows down.
So applying fertilizer then might not be ideal.
Unless the turf is consistently irrigated, it's often best to skip applications in July and August, or maybe just apply very lightly. Pushing growth during heat stress isn't usually helpful.
And what about that very first spring application in April? Any specific advice there?
Yeah, be cautious with nitrogen in early April. As the soil warms up, you naturally get a growth surge. Too much N right then can make it excessive, almost floppy growth.
Weaker perf, maybe?
Potentially.
So
So if you're putting down a granular pre-emergent herbicide then, which often contains fertilizer, look for formulations with lower N analysis, or maybe ones using controlled release urea, to avoid fueling that unwanted surge growth. Minimal N is often best in early spring.
Okay, now let's talk about that late fall application. You called it dormant N. That seems really common.
It is, and for good reason. We're talking applications made generally from early October through the end of October, maybe slightly earlier in the northern Midwest, slightly later further south.
And the idea is
Usually a portion of that nitrogen is quick release. The turf is still active enough to take some of it up before going truly dormant. It stores those carbohydrates over winter.
for a strong spring green up.
Exactly.
Yeah.
It provides energy for recovery and early growth next year. Now, if you use a slow-release source for that late fall application, very little nitrogen should release over the cold winter months when the ground is cold or frozen. So it essentially sits there, ready to go, acting like an early spring application when temperatures rise.
So it's almost like banking fertilizer for the next season?
Kind of, yeah. It's a very effective strategy.
What about the relationship between how often you apply and how much you apply each time?
There's an inverse relationship there. The more applications you make across the season,
The less nitrogen you apply each time.
generally, yes.
Yeah.
For really high-quality lawns, getting maybe 4 or 5 applications, the maximum single application rate is often recommended at 0.75 pounds N per thousand.
3/4 of a pound.
But if you have a program with only, say, 1 or 2 applications per season,
Maybe a more basic program.
right, then higher rates per application, maybe up to 1 or even 1.5 pounds N per thousand, can be justified, provided you're using predominantly slow-release sources that will meter that out over many months.
It really highlights that there's no single right answer. It's about matching the product, rate, and timing to the program goals and the site conditions.
Absolutely. It involves science, knowing these guidelines, but also art adapting to the specific turf, the weather, the client's expectations. There's flexibility.
And speaking of adapting and using smart strategies, this seems like a good place to talk about specific technologies that help managers nail that balance of performance and responsibility. You mentioned EPIC earlier.
Yes. EPIC is a prime example, especially here in the Midwest. It's positioned as the leading polymer-coated urea, or PCU.
Polymer-coated urea, so that falls into the coated controlled release category we discussed.
Exactly. And it really embodies those goals of being efficient, economical, and environmentally friendly.
How does it work specifically? What makes it smart?
The core mechanism is that polymer coating we talked about. It protects the urea granule. Nitrogen release happens through diffusion.
Water vapor goes in, dissolved N comes out.
You got it. And the key is that this diffusion process is primarily regulated by soil temperature.
So as the soil warms up in spring and summer, when the plant is actively growing and needs more N,
The coating becomes more permeable, and the release rate increases. When it's cold, release slows right down. It naturally matches plant demand.
That is smart. It's self-regulating almost.
It's very effective. And those EE benefits, efficient, economical, environmentally friendly, they really play out.
Let's break those down. Efficient.
Efficient because it meters that nitrogen out precisely over weeks or even the whole season. This drastically reduces the chance of those unwanted growth flushes you get with quick release. Less surge growth, less mowing, less risk of burn.
Okay. Economical. How does that save money?
Think about the operational savings. Fewer applications needed means less labor, less fuel for transport, less wear and tear on your spreaders and trucks.
And less wasted nitrogen, I assume.
Definitely. Significantly decreased nitrogen loss through leaching or volatilization means more of the N you pay for actually gets used by the plant. That adds up on the bottom line.
And environmentally friendly.
That ties right in. The polymer coating physically protects the nitrogen. It keeps it from being lost to the environment through volatility, leaching, denitrification, runoff. It's just a much more contained, responsible way to deliver nitrogen.
Does EPIC come in different release durations?
Yes, that's key for flexibility. They offer various longevities. A 60-day, which is a great fit if you're replacing stabilized end products or need shorter-term control. Then there's 90-day, 120-day, and even a 180-day for season-long feeding.
And you can mix these.
That's often the best strategy. Blending multiple EPIC longevities in your mix, that gives you a really smooth, extended release curve. It allows you to make fewer visits to a property.
Which hits that economical point again?
Exactly. Fewer trips, but you're still delivering that consistent, healthy, reliable turf quality your customers demand. It's precise nutrition over the long haul.
And because it's controlled release, you mentioned potentially higher application rates are possible.
That's right. Because the N isn't released all at once, higher single application rates are feasible and quite common with products like EPIC. Putting down 2, even 2.5 pounds of N per 1,000 square feet in one go isn't unusual, allowing for those much longer intervals between applications.
That's a significant amount, but safe because of the coating technology.
Correct. The control is built in.
This has been incredibly informative. Wrapping things up, for the professional turf managers listening, your commitment is always to deliver that consistent top-tier performance. No compromises.
That's the job. And hopefully this deep dive provides some valuable insights to help you continue doing just that, making smart, efficient fertilization choices.
Key takeaways seem to be: really understand your nitrogen sources, the differences between quick, slow, coated, stabilized. Optimize that timing and rate based on the turf, the season, the region.
And embrace those best management practices for environmental stewardship. They're non-negotiable.
And realizing that advanced controlled release options like EPIC here in the Midwest offer a really powerful tool, a way to hit those goals of quality, efficiency, and responsibility all at once.
They really do represent the cutting edge for achieving that balance.
So as you plan out your programs, maybe a final thought to consider. Beyond just getting great results this season, how do the choices you make today about fertilization impact the long-term health of the soil, its resilience, its sustainability?
That's a great point. What kind of legacy are you building, not just for the turf itself, but for this soil resource for future managers and for the communities you serve? It's about the bigger picture.
Something to think about. Thanks for joining us on The Deep Dive.